sir. Hello, Brahma sir. Hello. हाँ ब्रह्मा सर તમે લીવ કરી શકો છો. हेलो हाँ सर
ये सर को आने दो थोड़ी देर. विजय शाह सर आ जाते हैं तो दैट इज गुड, क्योंकि उनको लगना चाहिए वी आर प्रेजेंट.
ओके તમે તમે જોઈન કરી દીધા. ઓકે ઓકે જોઈન થઈ ગયા સર તમે. વોઇસ જોઈ લઈએ.
ગુડ ગુડ.
हेलो
हाँ हेलो सर તમારો વોઇસ આવે છે સર. Completely. Your voice is audible. Now we will start. Good. Hello, Brahma sir.
Yes sir.
Sir, Shah sir join થઈ ગયા છે. So they will start the session. તમે સર રિલીવ થઈ શકો છો સર.
Okay, Vijay Shah sir, namaskar.
हाँ नमस्कार सर. Sorry for delay.
Hello.
Yeah, sorry for some delay.
No sir,
no problem sir. I extend my sincere thanks and gratitude to you. And definitely our participants will enjoy your session. So I think without taking more time, I think over to Dr. Vijay Shah sir.
Yeah.
Thank you sir.
Okay. So Kaushal,
yes.
Where I have to start?
Yes, definitely you may start sir. You may start.
I can straight away start my session.
No sir, just give us 2 minutes. Only 1 minute sir. Okay. 1 minute sir. 1 minute hold on. Nirav sir.
So
hello Nirav sir.
Yes sir.
Please introduction sir no apno.
Yes sir.
Start the introduction part.
Good morning once again to everyone. It's time for the first session of the first day, which is on bridge engineering for infrastructure development. We have with us Dr. B.J. Shah as an expert. I welcome him on the behalf of our Government Engineering College, Dahod. It's a privilege to have you serve with us. He is working as Principal of Government Engineering College, Modasa. After getting his bachelor from Birla Vishwakarma Mahavidyalaya, Vidyanagar in 1988, he got his post-graduation in Computer-Aided Structure Analysis and Design from LD College of Engineering, Ahmedabad in 2001. He got his doctorate degree in Structural Engineering from Sardar Vallabhbhai Regional College of Engineering and Technology, South Gujarat University, Surat. And now it's SVNIT Surat. He has guided 4 PhD scholars and 15 postgraduate students. He has published more than 30 technical papers in various journals, conferences, and seminars. He conducts many training programs and gave expert lectures in many of them too. He also worked as an expert in various committees in All India Council for Technical Education, Gujarat Technology University, other reputed universities, Directorate of Technical Education and Education Department of Gujarat, State of Technical Services. Sir has a wide experience of bridge engineering. Let us take benefit of that by welcoming him on this occasion. And I kindly request Sir to share his wisdom of knowledge with all of us. And thank you.
Hello.
Yes sir.
Yeah, good morning to all. And first of all, let me sorry for having some delay, because as we know that these gazettes are not in our control. Many times what we want and what we get. Janmashtami, and I think let us on this auspicious day, the session, the first FDP is going on. That is the fundamentals of structural and geotechnical engineering for the sustainable infrastructures development. See, as we know that the infrastructure
sir,
is
your PPT is not visible, sir.
PPT is not right now. I have shared. It is just 2 minutes.
Hello.
Yeah.
Vijay Shah sir.
Yeah.
Yes sir. Keynote speech આપી દો આપ પહેલા sir આપ.
એટલા માટે જ. Yeah.
Please share
I'm
your
just
keynote
giving a few things as far as the infrastructure development is concerned, and then after we can start our session.
Okay.
Right?
Okay.
So basically, as we know that the infrastructure development is a key, what we can say, the key thing for any nation, as we know. And particularly in the last decade, there is a lot of change that is made as far as the infrastructure development is concerned. And as we know that this infrastructure development is related to the happiness index of the people, as well as the strength of any nation. As you know that many developed countries, basically we called it developed because their infrastructure facilities are to a very great level. Whereas the developing countries are developing their infrastructures in a stage by stage, and slowly and gradually they are converting into a good nation. So infrastructure is basically a key things for any countries. People also like to see it. But the major difficulty is particularly in this infrastructure development. The 5 points are there which are the main issues for the infrastructure development. If any countries just take care of this 5 point, I think one can easily move in the development of this thing. The first and very important thing, that is a financing. As we know that all the infrastructures project needs a huge finance, right? And that is why most of the time developing and underdeveloped countries are facing difficulties regarding this financing part. There has to be a very sincere effort and a proper management to get the finance of any infrastructure project. And finally, for the success of any infrastructure, for success in the sense that whatever we have initially decided and finally it is completed, most of the time we found that there is a large difference in the estimated cost and the final cost. And that is why one has to have a proper management for the finance to have the success of this infrastructure project. Another important thing, that is a land acquisition. As we know that all these infrastructure project needs a very wide space, land, and many times whenever we have to acquire the land, it creates a lot of problem from the people. So there is a need to have a proper rules and regulation for this land acquisition, so that everybody will satisfy. And I think the project, most of the time, there is the delay in the infrastructure project is also because of this land acquisition. It is a very, very crucial part for this infrastructure project. Third and very important thing, that is a clearance from the numerous agencies. As we know that many agencies are there from which this project needs a clearance. And hence, if the government procedures are not proper, government has to lay down the proper procedures to get down the clearance from different agencies associated with it. So this clearance, that is again a government part. And if it is to be a properly laid norms are there, it will be very clear. Fourth and very important thing, that is an environmental impact assessment. As we know that nowadays this is a great concern for all the infrastructure projects. Environmental impact assessment needs to be carried out properly, and accordingly it is to be followed at the time of the constructions. Otherwise, it creates a big impact on the environment, and finally it continues for a very long time. So this is a very big issues for the infrastructure development project, environmental impact assessment. If it is not being done properly, then it creates a lot of issues later on, and the next generations, the coming next generation has to suffer for that. And last and very important thing, most of the time we are not cope up the situations properly, and that is a pre-construction planning. Whatever projects which are going on for the construction, if it is not properly planned how the thing is going to be there, then it creates finally at the end, as we know that whatever estimated times, durations, cost, everything are there. And finally, if we see the final time, final cost, everything, there is a large difference between these two things. Most of the developing countries are facing these difficulties for the pre-construction planning. Most of the time, we are not giving enough time proper time for the planning, and then after we can start in hesitation all these construction projects, and finally at the end we can see the trouble arised, the gap, there is a very large gap between these two things. So I think these are the bottlenecking points for the infrastructure's development part. And other important thing, that is the environment, the climate. So that is why the concept for any sustainable development, when we are talking about these infrastructure projects for sustainable development, three things which we need to take care properly. The first thing is the economy. Economy is always there. Second thing is the environment, and third thing is the society or the social. These are the three key issues for any sustainable infrastructure development projects. And if we can tackle these three things properly, then I think any projects are going to be sustainable for a long time. Sustainability is the important issues for any construction projects, and particularly for the infrastructure project, it is having a value for that. So I think the theme which is suggested by the organizer, it is a very, very appropriate, for because we are transforming from, we are moving or transforming from developing countries to the developed countries. So in this transformation, the sustainable part, sustainable infrastructure is playing a very, very important role in this transformation. So I'm really congratulating the team of GEC Dahod for having such a very what we can say the topic which is really a need of the today's. And I'm sure that the first phase, I was also associated with the first phase of this training program, where also the fundamental parts were discussed. And in this advanced stage, again, we are going to discuss the few things as far as this thing is concerned. So hope this 5-day session, starting from a very auspicious day of Janmashtami, going to be very crucial. Going to be a very crucial for this thing, right? So
thank you very much, sir. Thank you very much, sir.
Congratulating, and I wish you all the best for this 5-day session of this training program. Right?
Thank you very much, sir, for your kind words, sir. I think let us start with our session, sir.
Okay. Yeah. So let us start with the today's session. I'll first of all share my presentation, and then after, because we are already late for about 20-25 minutes, so I'll straight away share my screen and we'll move ahead. Is my screen visible?
Just wait for 1 minute, yet not visible.
Yeah.
No, sir, yet not visible, sir.
Just a minute. Is it not visible?
Yet not, sir. Let us be wait. Yes, sir. I think something. Just in 1 minute. Sir. Yes, it is visible, sir. It is visible. Hello, sir. Your PPT is visible now, sir.
Okay. So let us start with the today's session, the first session of the FDP, that is fundamental of geotechnique and structural engineering for the infrastructures development. I'll be talking today on the bridge design and construction for the infrastructures development. In the first FDP, that was just in the month of June or so, it was the fundamental of geotechnique and structural engineering for sustainable infrastructures development, where we have delivered the topic on bridge engineering. Now this time, that is, we have taken the bridge design and construction, and this time we are going to focus a little bit more on the design and the construction aspect of the bridges, which is one of the very important structural elements of the infrastructures development. So let us start with the today's presentation. So bridge is basically a structures. Just little bit information about the bridges. I think most of the time you are knowing what bridges is there. But just start with what bridge is. It is a structures which covers a gap to carry a free flow of the transport. Bridge is basically a most significant component of the transportation system in case of communication over the spacing gap or whatever reasons such as aquatic obstacles, valley, gorges, etc. Generally, bridges carries a road or a railway across a natural or artificial obstacles like river, canal, and other railway or road. Bridges is a key element of the transportation system, which carries the heaviest responsibility. That we can see that whenever on any transportation system, when we put any transportation system is basically divided into two parts, the roads and the bridges. And let us see that when I'm getting difficulties in. And once again, just stop and I'm getting difficulties in slide transition. So as we have seen that the bridges are expensive, and if you just look about the cost per kilometer of the bridges, which may runs from even 50,000 to 1 lakh per sometimes 50,000 to 1 lakh per kilometer per meter. So that is why if the bridges fails, the entire system fails. So we can just have the importance of the bridges, particularly in comparison to the two main components of the highway system, that is a road and the bridges. So bridges are important in that way that if it is going to fail in this entire chain or in a link, then the entire transportation system is going to stuck off. And finally, we cannot get the benefit of the network which we have established. So in that way, the bridges are going to be a very, very important structural configuration of this entire network. As per the ASTRO, any structures having an opening not less than 6 meters that forms a part of the highway that is located over or under the highway, that is known as a bridges. So whenever any opening is there more than of 6 meters or so, that will be and that is to be covered, that is known as a bridges. So the bridges are in that way important from many perspectives. From people's life, there are many aspects are there: social aspect, education aspect, employment, entertainment. So from social aspect, from economic aspect, and economic is definitely playing a very, very important role because we are living in a developing countries. So where majority of our what we can say the budget that will be going for the people's expectations, for the people's healthy education, for the health. So majority of our budget part is going in the health and the education. The third priority that is coming to our infrastructure development. So that is why whatever we are going to pay, whatever we are putting, economy is always a matter of concern for us. And finally, politics. So from the politics point of view that we know very well, we have seen that nowadays there are a lot of tension which is going on between India and China, India and Pakistan, and all our neighboring countries. So these kind of bridges are playing a very, very key role in such political situations. So from many aspects, these bridges are important, and hence we have to be very well. We have to take it in a proper way. If we see the road infrastructures, particularly we are talking about the bridges, so that is why road infrastructure is playing an important role. Just have a look at some of the figures of these road infrastructures, which will have some idea that how huge this infrastructure is there, and huge capital is being involved. So that is why we have to be very well careful in the bridge engineering, bridge constructions, and the bridge design and constructions. If we see, the India is the second largest road network in the world, spanning a total 5.89 million kilometers up till now. The road network transports that is almost 65% of all the goods in the country, and 90% of India's total passenger traffic uses the road network to commute. If you can see, the highway construction in India, that is increased at 70% of a compound annual growth rate between financial year 16 to 21. And despite this pandemic and lockdown situation, India has constructed somewhat about 13,000 kilometers of the highways in the financial year 21. In May 2021, the Ministry of Road Transport and Highways constructed somewhat about 1,500 kilometers of the national highway, compared with 850 kilometers in the May. Lakh crore under the national infrastructure pipeline in financial year 2019 to 25. So we can see that there is a huge investment is there in these road infrastructures, and that is why road and bridges are the part of these road infrastructures. So we have to give the enough importance and care while design and constructions. Let us have some government initiative. Under phase 1 of the Bharatmala Pariyojana, the Bharatmala, just to connect the various modes of the countries, the ministry has approved implementation of somewhat about 34,800 kilometers of the national highways in 5 years, with an outlay of rupees 5,35,000 crore. Under this scheme, 22 greenfield projects. So this is also important as far as the sustainable projects are concerned. Sustainable development is concerned. 22 greenfield projects, somewhat about 8,000 kilometer length, are being constructed. This is worth rupees 3.26 lakhs crores. The government also aims to construct 23 new national highways by 2025. And under Union Budget of 2021-22, the Government of India has allocated rupees 1,08,000 crore to the Ministry of Road Transport and Highway. So we can see a very huge investment is already sanctioned by the Government of India, particularly in these sectors. What is road ahead? The government, through a series of initiatives, is working on the policy to attract a significant investor interest. This is, as we have discussed, that the financing is the crucial thing in all the infrastructure projects. So that is why to attract the significant investors' interest, government has already gone for many initiatives. A total of about 2 lakh kilometers of the national highway is expected to be completed by 2022. And in the next 5 years, National Highway Authority of India, NHAI, will be able to generate rupees 1 lakh crore annually from toll and other sources. So as we need that when we go for such kind of a huge investment, there some monies are also required to be getting from that. So toll and other sources are there from which we can get money, and that will be again invested for the infrastructure development. So I think these are some of the government of India's initiative as far as the infrastructure development is concerned. And looking to this thing in my presentations, I have tried to cover, give importance more about the design and construction aspect of the bridges. See, we will see there are wide varieties of the bridges, so that is why the design of every bridges are not to be taken care. But conceptual, how the design is being carried out, and what are the prevailing methods of the constructions are there, what are the advanced construction practices are there. So I will focus, because these 2-hour sessions will not make you a master of the design and constructions, but whatever the prevailing practices are there. So my focus, particularly in this 1.5-hour session, is on these prevailing practices, particularly as far as the design and construction is concerned. right? So next 1 hour, we are going to discuss fully on the design constructions and the construction methodology. Advanced construction practices are there. So this thing we are going to discuss. Right? Let us start with the historical part. Right from the beginning, if we see the bridges are there, it's not a new thing. But as the time evolves, new and new techniques are also evolving. And nowadays, at the end of this 19th century, we are moving with a very long span bridges, modern long bridges, movable bridges. So these things are there. So that is why we are concerned with all these things. Is everything going okay, Professor Kaushal? Voice, video, audio, everything. Hello. Is it? Am I audible? Anyone? Participants? Hello. Hello.
Sir, please, sir.
Is it going on okay?
Yes, it is okay. Perfectly okay, sir. Perfectly okay.
Yeah. So in a historical part, we were discussing that it is not right from the human civilization, the bridges are there. Initially, we can see that the people were using just a log or slabs or rocks just to cross such obstacles. But slowly and gradually, it is to be put it in a very, what we can say, the scientific way. The Roman Empire, they have started the timber and machinery to make the bridges. Then after the European have started the iron, steel for making the bridges. And finally, in the 19th century, we have gone for a very long span bridges, the movable bridges and all the things. As we have seen, this is just the beginning to cross any obstacles are there. We have started with this thing, and we will see in the next couple of slides that how we can reach the construction, design and construction of the bridges are concerned. These are some of the ancient, some of the pictures of the ancient our country. People were using this Ram Setu we have used in this Ramayana. In the Ramayana, all these Lord Ram in association with all Hanumanji and all the monkeys, they have prepared such kind of a Ram Setu just to travel to Lanka. So this was the ancient part, but we have seen these are the small. These are the pictures the people were using just to cross such kind of obstacles are there. Now this will evolve in a more right way in the Roman period, and many machinery and stone machinery and the arch bridges that will evolve that was come up in the Roman period. And we have seen such beautiful stone and arch bridges came up in the Roman period. Then after in the Middle Age, we have come up with such kind of, again it is a stone arch bridges, and Guangzhou, China, that is developed a stone arch bridges of somewhat about length of 65 meter with a width of 9 meter, and beautifully that is to be built up in a in the era that is a 595 to 605 AD. So in those days, these type of bridges were constructed. Slowly, as we evolve, human being evolve more and more, beautiful bridges have come up. That is a suspension kind of a bridges, and that is come up on the river Ohio. That is the longest span of somewhat about 300 meter. The total length is somewhat about 650 meter. The clearance we can see that is a 30 meter. So this is a suspension bridge used for the pedestrian traffic purpose. But this beautiful bridge is really, it's a remarkable structures, and people would like to just visit such kind of places. In the 20th century, the Golden Gate Bridge, San Francisco, that is evolved in the 1937. That is again made up of a steel. Total length is 2,700 meter, width is 27 meter, height that is 227 meter. Longest span is 1.2 kilometer, 1.3 kilometer. Somewhat of the longest span is there. Vertical clearance that is somewhat 4.3 meter at toll gate, and clearance that is 67.1 meter at the tide. So see these beautiful bridges that is also come up in 1937. In our country, Havra Bridge, 1943, 8 lanes of the Strand Road, pedestrian and bicycle, both the purpose is there. That is to be made upon a Hooghly River. Suspension type cable, balance cantilever and the truss arch bridge is there. It is made up of a steel, 700 meter total length, width is 21.6 meter, 2 footpath, height is 82 meter, longest span is somewhat above 450 meter, and clearance that is a 8.8 meter. So one of the oldest bridge of our country, Ravindra Setu, known as a Ravindra Setu, that is to be made up in 1943. Milau Bridge, one of the remarkable structures. Whenever we are talking about the remarkable bridges, wonderful bridges, then the Milau Bridge is one of the candidate for that. Made up in 2004, 4-lane cable stay bridge. Total length is 2,460 meter. Width is 32 meter. Height that is 343 meter pylon above the ground. You can see that very tallest bridge. It is considered known to be a very, very tallest bridge. Many times when you pass on the Milau bridges, the clouds are also going to touch you, and you will get a very wonderful experience while traveling on the Milau bridge. Number of span that is 204 meter, 6 span of 342 meter, and 204 meter. Clearance above the ground that is 270 meter maximum clearance. So this is one of the tallest bridge of the today's, and which saves approximately 4 hours and 30 minutes journey time. So this is one of the wonderful bridge. River bridge, bridges to fill up the gap of a road or river. Whenever any natural drain or roads are there or railways are there, we need to cross this thing. Then road bridges or railway bridges. These are very common pictures in all the countries to cross the obstacles, either a river or the rail or the road. Then we can create such kind of bridges. This is another pictures of today's majority of the cities or big cities. Where if we talk about China or Japan or United States, many big cities are having such kind of flyovers. I think you can see the network of the roads which are just the things, and we have a multiple entry, multiple exit, grade separations. So high level underpass that crosses over a highway interchange or the intersection. So at the busy junction of road, any of road is elevated by the road. So these kind of pictures are coming up at many cities in our country also. As the urbanization is going on, there is a need of going for such kind of many flyovers in a city like Delhi Metro, even in Ahmedabad also. These kind of the pictures are will be coming up in the near future. So these are the needs of the today's, because as we know that the urbanization is going on at a very high rate. So to match with such urbanization, there is a need of such kind of flyovers and to just scatter the traffic problem. There is another new things which is found in most of the metro cities or big cities. that is metro. The bridges to be constructed for the metros, especially a very long bridges, maybe over the road or under the ground, underground. These kind of metro bridges are coming up in majority of the cities in our country also. So where we need to create a bridges. So bridges to carry a railway load or to cross a rivers or the road. We can see the picture of a monorail. So here, this is a monorail, and we can see that as the many big cities, these kind of the bridges are the needs of the today. So railway bridges, particularly a metro rail, wherever it is to be there, these kind of bridges will be coming up in the near future. And as we know that urbanization, whenever going on, the metro bridges are there. So we need to have such kind of foot over bridges. We need to have a skywalk. We need to have a subway. So in majority of the cities like Delhi, Mumbai, and the next level cities also, foot over bridges, skywalks, subways, that will be features that you are going to find out in majority of such metro cities. Right? So that is particularly useful for the pedestrian purpose because they cannot enter into a mainstream of the vehicle. So to cross the mainstream of the vehicles, there is a need for such kind of a pedestrian bridges. So this is also an essential thing, that the bridges are not only used to carry the vehicle, but just to carry the people, to carry the traffic, pedestrian. There is also a need to provide such kind of a pedestrian bridges. So foot over bridges, skywalk, subway, different kinds of other things have to be there. And this is finally government has also decided to go for some of the specific highways where the aircraft can also land. It's not necessary that it can land only on the runway, but in some emergencies it can also land on the national highways. So the national highway authorities have already started to think in this direction and planning to have some of the national highways that can be also used for the aircraft landing. So this is the final right now. Up till now, the people have already started. Government has already started to think in these directions for landing of the aircraft. Such kind of bridges are to be provided for landing of the aircraft. So this is all regarding the development which is going on. Again, this aqueduct, this kind of aqueduct, of course, it was a picture of very ancient India, but it is also used for the bridges are also used for the same purpose. Bridges that constructed to convey a water over an obstacle, such as a valley, commonly used particularly in the Roman, such kind of structures found during the Roman Empire, and such kind of intact structures, as we have seen that the intact structures are there, and through the intact structures, the pipelines, waters are to be provided to the city. So we can create such kind of aqueduct. So the thing is there that such kind of aqueducts are also provided during the Roman time. So in this way, if we can classify, there are various ways for the classification of the bridges. We'll just have a few of the things here. According to function, as we know, it may be a railway bridge or river bridge or whatever purpose, whatever function is there. Accordingly, the bridge is being classified. According to the material of construction, it may be a concrete bridge, it may be a steel bridge, it may be a timber bridge. Right now, the pre-stressed concretes are also widely used in the construction, and even composite, steel and concrete composites are also used for the construction. So it depends on what kind of materials we are going to use it. Accordingly, it is also classified. Form of the superstructures, that is playing a very, very important role, and it all depends on what is the opening that is we need to put it. what is a span that is required to be put in. Accordingly, the form of the superstructures will be decided. So the form of the superstructures is one of the major thing, because many times there are constraints of placing the pier or placing the abutment, and that is why the span is to be decided considering all these constraints. And that is why every time we are not able to put in the same type of superstructures, and that is why depends on the span arrangement. There are different kinds of the superstructures that is playing a very important role. We are going to discuss this in the coming slide, particularly that what are the suitable form of the superstructures for the different span range, and that also economy is also associated in attached with the form of the superstructures. So that is why superstructures and substructures. Finally, when we talk about the economic consideration, we need to see that the 50-50 contribution would be there for superstructure and substructures, and accordingly, the span will be decided. We are going to discuss in much detail in the coming session as far as this form of the superstructure is concerned. According to interspan relationship, most of the time we were using a simply supported discontinuous bridges, but as the length of the bridges would be more, and that involves more joints. So to reduce the joints, we may now go for continuous bridges. So the interspan relation is also, accordingly, the bridges is also classified. According to the road level relative to the highest load level, depends on whether it is a submerged bridge or the thing, so that will be there. According to the length of the bridges, this is basically related with the length of the bridges, and according to the anticipated type of the services and the duration of the use. Many times, for some short duration, also we need to create a bridges, particularly in the defense sector. For short duration, bridges are also to be required for defense and other purposes. So it depends on the anticipated type of the services and duration, the bridges is also classified. This is, I think, known to everyone. Basically, when we talk about a component, then the superstructures, that is the structures which receives the load directly. So it is a superstructures, and then after the superstructures rest on the substructures, and in between superstructure and substructures, we need to provide a bearing, which is a important thing, because very heavy loads are going to transfer from superstructure to substructures. So bearing will be provided in between, and this is the heart of the bridge. Small element is there, but the functioning of the bearings is very important for the functioning of the bridges. So that is why the superstructures, substructures, again in the substructures below the ground, that is a foundation, that is also part of the substructures, and foundation, that is depends on the type of the ground condition which is available to us. What is the seed bearing capacity, what is the settlement characteristics, soil characteristics. So based on that, the type of foundation to be decided. So foundation is also a very, very crucial element for the stability of the bridges. So if we see the entire design and construction of the bridges, the substructure part, superstructure part, substructure part, and foundation, all the three elements are all equally, what we can say, the important. Any of the link is going to fail, there is a failure of the bridges. So that is why we cannot just neglect any of the part, whether it is a superstructure, whether it is a bearing, whether it is a substructure, whether it is a foundation. Every element is a critical element, crucial element, and failure of one element will put the entire bridge into a unused or the failed condition. So design of such bridges, design of the bridges is playing a very, very important role. And I think very expertise is required in the design of the bridges, because it involves a very sound engineering. Uh, uh, Sound engineerings are required. Knowledge of the engineering practices and everything are to be very well required here, and that is why and it is a very huge structures, involves a huge mass, weight, money, everything are to be there. So that is why the failure of the bridge cannot be acceptable in any condition. In any situation, the failure of the bridge is in the initial period, during the construction period, or during the initial period of the life is not at all acceptable as far as the bridges are concerned. Unless and until very, of course, most of the bridges are also to be designed for the nature loading. Nature loading, just like as the seismic load, the wind loads, and other nature's loads are nature's imposed loads are there. So, considering the importance of these structures, the life of these structures, all the nature loads as well as all other loads are also to be considered in the design, because we cannot take any risk of failure of the structures in the initial period of the life. So that is why the design and construction of the bridges are a very, very important issues, particularly in these entire road sectors and the infrastructures. So next few hours, next few slides, we are going to discuss some of the key aspect as far as the design is concerned. What we have to take care in the design. So first part, let us have the superstructures, and we have seen that there are various forms of the superstructures. Depends on the span, what span we are going to use it, and accordingly there are various kind of the superstructures. If the span is small, many times there is a range of 6 meter, 10 meter, very small span is there. We can go for a slab type of a superstructures. Slab type of a superstructure is just like as a slab which is provided in the building, but here the thickness of the slab is not as the thickness we provide in the building. In the building, we normally go for a 4 inches, 5 inches, or 6 inches thickness, but here it may be in the range of 600 mm, 700 mm, 1000, even 1 meter, or maybe sometimes more than 1 meter, 1.2 meter or so. So thickness, very thick slabs are provided, and we may even go for a variable thickness, because as we know that there is no need to have the same thickness considering the various forces that are to be induced in the section. Most of the time bending forces, bending moment, shear force. So looking to the forces which are induced in the section, there is no need to provide a uniform thickness. We may even go for such kind of a variable thickness. So at the support, we need to have a more thickness. So we can provide a more thickness considering the shear consideration. And as we move away from the support, we can reduce the thickness. So solid slab type of superstructures, composite slab, voided slab. Voided slabs are also very important thing. Ultimately, the thing is that the moment of inertia of the section we need to increase, and how we can get it. So where the voided slab is also one of the important candidate. Keeping the same weight, introducing the wide or a lightweight material, we can increase the thickness, and in that way we can increase the moment of inertia, and in that way the flexural strength will be increased. Right? So slab type of superstructures are good in a certain span range. Maybe a lower span range, smaller span range is there. We can go for a slab type of superstructures. Then we can go for slab and beam, which is one of the most common type of superstructures. So here the beams are there, and the slab. So sometimes it is also known as a T girder or I girder. So girders that is I or T girders are provided and over which the slab is provided, right? So this is called a slab and beam type of a superstructures. Most conventional type of a superstructures you find in majority of the bridges, and that is used in a moderate span range ranging from 10 meter to 20 meter or even up to 30 meter. We can go for such kind of, by playing with the different materials, we can go for such kind of a slab and beam type of a superstructures. Cellular and box type of superstructures, that will be in the next range. So we can go for creating such kind of a close structures, box kind of structures, and this box type of superstructures is also a good in the span range higher than whatever is required for the slab and beam type, and it has also a very good torsional resistance. So that is why when we go for providing in case of a curved, whenever there is a curvature, we see alignment. We are not alignment is always depends on how the road is going on. So basically, when we provide the bridges on the alignment of the road, many times the curved, skew, such kind of things are to be there in the bridges, in the bridge alignment. So whenever skew bridges are there, curved bridges are there. So such kind of a cellular box type of a superstructure is very, very useful and economic also. So again, with playing a different material like RCC, PSC, we can go for a cellular type of superstructures in a higher range of, let us say, 20 meter to 40 meter or even up to 50 meter, one can go for a cellular kind of superstructures. Next important part, that is a bearing called a heart of the bridges. If the bearing fails, the entire bridges are going to fail. So slowly, so this bearing, various types of the bearings are to be provided just to allow the movement, different kinds of the translational movement, rotational movement, so that the additional stress is not developed in the structures. So to avoid the additional stresses developed in the structures, the proper use of the bearing is a very, very important thing and very, very important design criteria. It is also a design criteria. Designer, the bridge design engineer has to properly decide the choice of the bearing, so that all these deformations which are going to take place due to the loading in longitudinal direction, transverse direction, rotational directions, it will be easily taken care by the bearing and additional stresses would not develop. Otherwise, these additional stresses would create a trouble. And finally, the stress when the excess or the overstressing would take place in the structures, this overstressing would also be one of the reasons for a progressive failure of the structures, right? So and with the use of properly fixed bearing, free bearing, guided bearing, elastomeric bearing wherever it is required. So by having a proper choice of this bearing, one can have a one can give a life to the bridges. Substructures, most of the time, substructure is just like as a cantilever element. Like cantilever element, at one side it is a fix, on the other side it is going to rest the superstructures and transfer the loads of the superstructures on the substructures through the bearing. Bearing is a place through which the loads of the superstructure it is going to transfer. So various component of this superstructure, that is a cap. Cap is the initial element which receives or what we can say, which is the house for placing this bearing. So it is a house of placing the bearing, and then below the cap there is a stem. Cap is always keeping a larger or wider just to keep the superstructures in position, or just to accommodate to house the superstructure. So that is why it is a longer. longer thing. We can just see that our hands, as we expand our hands, are just like the task of the cap. So whenever very heavy loads are there, we can expand our hands and just accommodate this load. So just to have a very large, what we can say, the width of this the bridge or superstructures, to accommodate the bridge of width of the superstructures, we need to provide a cap. So cap is always maybe equal to or little lesser than the width of the superstructures. And most of the time it is cantilever. There are various shapes to be provided. Sometimes it is a wall type. So if we see this picture, this is a wall type superstructures. So wall type superstructure is there. This is a column type of superstructure is there. So column may be provided either a rectangular or circular, whatever shape will be there. So column type of maybe hollow circular. Sometimes multiple columns are also provided. You can see here that these are the multiple columns are provided. So depends on what is the width of the superstructures. But we can consider that substructure, it is nothing but the legs of the human being. As we know that what is the importance of the leg for the human being. Same thing we can say that the substructure, it is nothing but it is the legs of the bridges. If the legs are going to fail, then the entire bridges are going to collapse. So that is why we have to be very, very careful for designing this substructure part, and particularly a stem part. Whatever shape will be there, whether it is a circular, wall type, hollow circular, or multiple column, whatever the things are there, we need to be very, very careful while designing the substructures. And foundation, because as we know that all this entire heavy load is going to transfer on the ground, so that is why we have to go for study the ground characteristic properly. Geotechnical investigation needs to be carried out properly, and accordingly we need to understand, we need to determine what is a soil bearing capacity, what is a settlement, and all the related tests which are required that need to be performed to decide the type of the soil. And based on that we can decide either we can go for a shallow foundation or we can go for a deep foundation. Open foundation, that is a category of a shallow foundation. Else otherwise we have to go for a deep foundation, where we may go for a pile foundation and the well foundation. So deep foundations most of the time is desirable and provided in majority of the bridges, because very heavy loads are going to be transferred on the soil, and if the soils are having a lesser bearing capacity, then it is desirable to go for a pile foundation or well foundation. Earlier well foundations were used, but nowadays the mechanizations are available, and so that unless and until pile foundation is not suitable, we can go for well foundation. Otherwise, majority of the places the pile foundations are very much suitable, and appropriate mechanization is also available for construction of the pile foundation, and hence the pile foundation is most suitable for particularly for the bridge foundation. So this is once again just to have the idea. Superstructure, that is this part is known as the superstructure, and this part is known as the substructures. Again, in the superstructures, this is a very traditional type of a superstructure, that is called a T-beam, T-girder type of a superstructure, or slab and girder type of a superstructures. So where this is basically the deck. So deck on which the vehicles or the pedestrian, whosoever are there, these are going to move. So deck is there, and then the deck, below the deck, the girders are provided. So this type of T-girder type of a superstructure, or slab and beam type of a superstructure, which is one of the most common type of superstructures in the bridges. And that is why in today's session, we are also going to discuss particularly some of the design aspect of this T-beam, T-girder type of superstructures, how it is to be designed, what kind of loads are there, and everything that we are going to discuss about this thing. Girder may be a RCC girder or the pre-stressed concrete girder or a steel girder, whatever type of material is there. So the girder, as we have discussed, maybe a concrete girder or a steel girder. In a concrete, it may be RCC or PSC. And these are very long girders because these are called a longitudinal girders. Basically, it is to be run along the longitudinal direction of the bridges. So, which are very long girders, and there is a possibilities of the buckling of such long girders. Of course, long girder is at the same time the depth-wise is also concerned. It is a very long depth, so that is why there is a possibilities of a bending or buckling of the girder. So just to control the buckling or bending of the girder, the diaphragm, or many times it is called a cross girder. So this diaphragm or cross girders are provided at some regular interval. I'll show you some longitudinal scale sketch of these bridges where you will be getting this thing in more detail. And below the girder, the bearings are to be kept. The bearing is to be put it on the pedestal. Many times this kind of a pedestals are provided. This pedestal is resting on the cap, and then the cap will be there on the pier or abutment, and this pier or abutment finally below the ground there may be a open foundations or a pipe foundation. So this is the entire picture of the things. Again, we have seen the superstructures. We have seen various kinds of the superstructures, like solid slab type of superstructures, may be made up of RCC or PSC. Voided type of a slab, voided slab type of superstructures, again to be made up of RCC or PSC. PSC, PSC stands for the pre-stressed concrete, which can be used for a higher range. Whatever range is available for the solid slab type, so RCC will be used for the lower range, and PSC will be used for the higher range. RCC multi-girder system. Multi-girder system maybe because it may be a 3-girder, 4-girder, 5-girder, depends on what is the width of the bridges. So accordingly, RCC or PSC multi-girder system, box type of a system, RCC or PSC box type of a system. And these all the red color which you can see are used for a longer span, steel type of a superstructure, steel RCC composite type of a superstructures, balance cantilever type, cable suspension bridge, boosting. So these all the options are particularly available when you will be going for a span range more than 40 meter, 50 meter, 60 meter. So then you can use the superstructures. These red color names which are suggested here. So this can be used. Otherwise, conventionally, you may be going for a slower slab type or a multi-girder system or the box type. Up to 40 to 50 meter, these are suitable. Beyond that, one has to think of a appropriate form of the superstructures. So earlier practice of the superstructure, that is a girder and slab type or a box girder types. Girder and slab type system was more prominent due to the majority of the bridges. In the long span, because nowadays the long span bridges are started, so we may go for continuous or we may go for segmental construction. Construction techniques is also playing an important role, and here we are also going to highlight some of the construction technique that is a segmental construction techniques, how it is being carried out. Today's it is widely used in construction of the majority of the bridges. It may be cast in situ or it may be precast, steel concrete composite construction, extra dose kind of the bridges, cable stay, suspension. So these are the different forms of the bridges are known, but that what forms are used particularly in the bridges. So these are the different things, different types of the superstructures. just have some of the sketches, actual photographs of the things, solid slab. Particularly when there is a question about this clearance, we are not able to get enough clearance, then we may go for a solid slab type of a superstructures. So clearance plays a very important role, and we can go for a shorter span, and clearance is there. We can also go for such kind of a voided slab, voids are to be incorporate. So the things are there. Multi-girder system. So see, these are known as longitudinal girders. So longitudinal girders are running in the longitudinal direction, and in between at some interval, you can see that such a cross girder or the transverse girders are also to be kept. Just to keep the longitudinal girder into a position at a regular interval of let us say 6 meter or 6 meter, 8 meter, or up to 10 meter, we can go for providing such a diaphragm or called a cross girders. So diaphragm or cross girders are provided to keep the longitudinal girder into position. Otherwise, there is a possibility of buckling of the girders. The thing is there. This is a prestige girders. Of course, just by look, you cannot differentiate. But these kind of blisters many times provided, so from which the pre-stressing of the wires can be carried out. It may be an external pre-stressing, it may be an internal pre-stressing. So entire scheme one has to decide whenever we go for the pre-stressed concrete bridges. Pre-stressed concrete design, it is a separate task, separate issues. It involves the knowledge of the pre-stressed concrete design. So here we will not discuss much about this pre-stressed concrete, but whatever philosophy we are going to apply for the RCC bridges, it will also apply to the pre-stressed concrete bridges. In addition to that, some of the knowledge of the pre-stress, like providing the cables, the losses of the pre-stress, and all the related things which will be taken care additionally. So whether it is a reinforced concrete bridge or pre-stressed concrete bridge, as far as the design philosophy is concerned, there won't be a much difference. But additional knowledge of the pre-stressing is required here, whether we go for a pre-tension, post-tension, so pre-stressing techniques, and all these additional things are required. Pre-stressed concrete bridges are widely, it is to be used for the higher range. So that is why it is desirable when we have to go for a higher range. This is a box type of superstructures, and see this kind of a box may be made up cast in situ, or it is just like as a precast made up in a casting yard, and then after it is to be transported on the site and then connected on the site. So this segmental construction practice segment, instead of going for the entire full cast in situ construction, we can go for a precast segment, and then after it can be attached or joined on the site. So we are going to see some of the photographs, some of the videos of such kind of a segmental constructions to have some more ideas that how the construction will be carried out. So these are cable suspension, bowstring girder, arch bridges, all the things are there. These are some of the recommendation as far as the superstructure is concerned, because it involves the economy also. And when we are talking about the design, span to depth ratio is more important thing. So for span up to 10 meter, RCC solid slab is suitable. 10 to 20 meter RCC multi-girder slab is suitable. 20 to 30 meter PSC girder box type superstructure is suitable. 30 meter above PSC box girder or PSC T girder suitable. Above 40 to 50 meter PSC box is suitable. And when span more than 50 meter, one can go for different options like truss bridge, suspension bridge, cable stay bridge, bowstring bridge. So different options are there. One has to try for that to ascertain the cost economics. These are another components of the superstructure, that is a deck, wearing coat, footpath, safety curb, railing, expansion joints. So whenever we design the bridges, we should also have to have an idea of all the things. Carriageway bridges, carriageway width. So carriageway width is the width where the traffic is going to pass. So this is basically known as a carriageway width, so in which the vehicles are going to move. Depends on the traffic survey. One can decide the what is the width of the bridges needs to be provided, whether it is a one-lane bridge or two-lane bridge or multi-lane bridges. So that all to be decided for the traffic survey. Traffic survey is required to be carried out, and what is a PCU that is to be come up, and from that the number of lanes and everything will be decided. So for planning, there are certain codes available for the planning of the bridges. So that needs to be studied for all these things. And so whether we go for a two-lane bridge with without footpaths, here the footpath is not provided. When the footpath is provided, then this is a footpath, this is a safety curb, crash barriers, railing. So these are the different components because all these components ultimately have some load and that is to be properly accounted into a design. So that is why we need to understand all this terminology, what is called a carriageway width. Again, on the carriageway, what kind of a bearing codes are provided, what is a footpath, what is a crash barrier, what is a railing. So these things are required. These are the different 4-lane bridge, 6-lane bridge, culvert. As we have seen many times, the culverts are provided over the obstacles, right? So what is a culvert? All these things are given in the IRC, Indian Road Congress publications are there. So IRC publications, one has to refer to decide the planning of all such bridges. Yeah, so these IRCs are available. Footpath, if it is there, width of the footpath needs to be kept, particularly in an urban road. Whenever we provide a bridges on the urban areas, there is a need to provide a footpath so that the people can walk over it. And where the footpath is not available, because there may be a constraint of the space. Space is always a constraint in the urban areas, so one can go for at least provide a safety curve. So these kind of a safety curves may be provided. Safety cars may be provided on the national highway or maybe on the state highway, national highway, wherever such possibilities of the pedestrian over the bridges. So we need to provide at least a safety curve if the footpath is not able to provide it. Right, railing is compulsory. Whatever kind of railings are there, if the footpath is not provided, we can go for providing a crash barrier or the metallic crash barriers. If the footpath is provided, then we may go for the RCC parapet or the pipe railing. So depends on what kind of things situations are there. We may provide the railing. Otherwise, there is a possibility of overtopping the vehicles and that will fall on the ground. Expansion joint, that is essential to take care of the changes in temperature, creep, shrinkage. So the expansion and contraction is going to take place because of these natural things, temperature, creep and shrinkage, and various kinds of the expansion joints to be provided depends on what kind of the movement is going to be expected. So we can go for a strip seal. This strip seal type of a joint is a very common joint, but if the translation is more, then we can go for a modular strip seal joint. So either strip seal joint or a modular strip seal kind of a joint. So this can be provided just to take care of the movement of the bridges. Various aspects are there, but as the time is short, I am not going to discuss in much detail. Bearings already we have discussed for longitudinal moment, transverse moment, rotation, and various kind of the rocker, port bearing, elastic
Sir, your voice is not there. Hello? Sir, your voice is not there. Your voice is missing. Sir, PPT is visible, but your voice is not there. Reason. Can you mute? Why the mute is there? Hello, sir. Your voice is not there.
It is muted. Now it is.
Okay. Now it is okay, sir. Okay. Perfect. Okay. Voice
automatically it is muted. I don't know what happened.
Okay, sir. Next,
Okay.
sir. Actually, okay. No issue.
Yeah. So let us say that this is the look of what we can say, the longitudinal section and the plan. So that needs to be understand here. So longitudinal girder and cross girder, intermediate cross girders are provided, and particularly in the design, the number of girder plays an important role. Depends on what is the width of the superstructure. Based on that, we need to decide the number of girder. Keeping some overhang on both the side, overhang of let us say a 1 meter or 1.2 meter on both the side, and let us keep the ideal range of the spacing is 2.5 meter to 3 meter. So spacing between longitudinal girder keeping 2.5 meter to 3 meter, that is the economical range of providing a spacing between the longitudinal girders. One can decide how many numbers of longitudinal girders are provided. And as we have discussed, the cross girder and cross girders are provided at the end, and in between at a distance of 5 meter to 10 meter, one can go for a intermediate cross girder. So this is just a look of the things. Here the cross section is there, which gives you more clarity. Basically, the section is to be taken in such a way that it is a half section from the support and half section from the mid span. So that is why here the different look will be there. So this is a support section. Basically on this side there is a support section, on this side there is a mid span section, and section is also taken like ABC. So if we just have a look of the previous thing, so ABC is the section, this is the ABC from the support and then from the mid span. So this kind of a section is taken, so it looks like this, otherwise all the girders are of the same type. We need to have a somewhat more what we can say the cross-sectional area of the girder, particularly at the support. So this is a support section, whereas this is a mid-span section. In mid-span section, basically the bending forces will be governed, whereas on the support section, most of the time the shear forces are governed. So that is why we need to keep a more areas on the support section, and we need to keep a more lesser area in the mid-span section. But at the mid-span section, again, see, there is a need to form a such kind of a bulb so that we can accommodate more number of either cables or the reinforcement in the bottom side, because as we know that in the mid-span the bending moment will be maximum. So there is a need to accommodate a more either cable or the reinforcement in this bottom portion. So that is why the bottom portion, the bulb is required to provide it here. So this is a most common type of a section which we need to provide in the bridge design. Most of the time we keep a uniform throughout the same cross-sectional area throughout the entire depth, whereas we keep it here a I or T type of a section, particularly in the mid-span. Okay. So this is the common thing, and Another thing we need to understand, that is this part. That is the end of the section. So here at the end, we need to support a approach portion. This is called a approach portion. So in a approach portion, approach slab is provided. So that is a dirt wall. That is called a dirt wall is required to be provided here. So this dirt wall will accommodate the approach portion, so that whenever any vehicle will come in from a road and then move toward the bridge, so this approach slab is provided. So dirt wall needs to be provided. So this is some of the cross section of the T girder kind of a superstructure. See here that here in the carriageway portion, then after the end of the carriageway portion, some sort of the crash barrier is provided, and then after the footpath is provided, and then after the railing is provided. Okay, so because the vehicle cannot travel in the footpath areas and cannot move on the footpath areas, and it will not injure the pedestrian. So such kind of safety mechanisms needs to be provided. Some sort of drainage spouts are also to be provided, because water cannot be accumulated, and that is why we need to keep a certain slope or certain gradient, maybe on the one side or on both the sides, so that whatever rainwaters are there, it can be easily drained out from the wind. Because as we know that if the water will be accumulated, it will be penetrated in the structures, and finally the structures will be corroded. So this is some of the things which we need to see during the design, and the code which we need to follow. These are some of the code. IRC 5, that is for standard design specification. 6, this is particularly for the general features. IRC 5 is given for the general features. IRC 6 is given for the loads and stresses, particularly in the design. We need to study both the code. This is for the planning point of view, and this is for the design point of view, which loads are needs to be considered. And then this earlier code, this 3 and 4 number, which were earlier used, but now both these codes are to be combined together and put it into a new form, that is IRC 112. And this IRC 112 is particularly for the design of the structures, design of the bridges, which covers both the design, RCC design and distress concrete design. Earlier in the older code, the working stress methodology philosophy were used, but now in the new code, limit state philosophy is included. So all the bridges are now being designed for the limit state, considering the limit state philosophy. So the limit state philosophy is incorporated in the IRC 112, and which needs to be followed. So one thing we need to understand the difference between the buildings and bridges. Most of we have designed the buildings, so that is why we are much clear about the design of building. But there are a major difference. Few differences are there, and because of these few differences, the bridges are bridge design is somewhat little different than the building design. The first and very important thing is it has a less redundancy and the reserved strength. Okay, and that is why we need to be very, very careful in the design, because buildings are having a large number of redundancy, and as we know, in a redundancy, even if at the one places the hinges are going to form, again the redistribution of the forces will take place, and successively one by one, all the hinges, once it is going to be saturated, then after the failure will take place. So in a building, large number of redundancy is there, so it will not going for an immediate collapse. Whereas in case of a bridges, there is a less redundancy, and hence even a failure at one place will put the entire bridge to be collapsed. Right? So the thing is that second important thing is that in the bridges there are many non-structural components. Of course, we are not considering the strength of this non-structural component into our design, and that will help us the design. But in case of bridges, there is no such non-structural component that will help at the time of the collapse. So this will dissipate the energy, that will absorb the energy. We have seen in the buildings that during the earthquake, the load-bearing wall, whatever the walls are there, they have taken the energy, significant energy, and just save the structure, save the structural components. So many times, structural component absorbs the energy during the failure and save the structural component. These kind of things are not at all there in case of the bridges. Third important thing is different component of the bridges have different overstrength and the ductility factor. See, ductility plays a very important role to have a ductile failure, ductile behavior of the structures, right? So we understand the importance of this ductility, particularly for the earthquake resistant design. So same things also needs to be seen in the bridges, particularly for the earthquake resistant design of the bridges. Ductility, we are not able to put it everywhere, right? So that is why there are only few locations where the ductility is possible, which needs to be provided. Base isolation is possible, which needs to be provided. So that is why these things is different from the things. Low ductility and over strength and the connection of the superstructure and substructures is a weakest link in the bridges. We need to ensure properly in the design. Otherwise, majority of the failure of the bridges are going to take place from the connection part, right? So this connection is the crucial element in the bridges, and how to just take care that in the extreme condition, this connection is not going to fail, because if the connection is going to fail, the entire bridge is going to fail. And that is why failure at just one or two places can put the entire bridge into a out of conditions. Various loads that needs to be considered as per IRC 6, dead load, superimposed dead load, various different ancillary items like a wearing cord, footpath, railings. So that all will contribute into a superimposed dead load. Live load is a very, very challenging task to consider, because various different types of the vehicles are going to move with a different capacity, and hence there is a need of some sort of a standardization as far as the live load is concerned. Majority of the countries has made it standardizations and defined or given the hypothetical vehicle and the loads while considering the design. But sometimes when other load, whenever very heavy loads are going to travel from the bridges, one has to take care, and it cannot be immediately allowed to travel on the very heavy vehicle bridges. And first of all the detailed studies needs to be carried out, and then after it can be allowed. Vehicle impact, impact of the floating bodies, vehicle collision load, wind, current, particularly when we design the bridges on the river, tractive forces, braking forces, bearing, centrifugal forces when the bridge is to be designed in the curved area or the curved portion, buoyancy when it is to be designed on the rivers, earth pressure, temperature are always there, because there is a daily variation, seasonal variation, annual variations. So different variations are there. Deformation effects, secondary. Nowadays, I think the secondary forces are also going to be there because of the construction sequence. So what kind of construction sequences which we are going to use it? Erection forces. So different mechanization is used. So because of that, the erection forces are there. Seismic force, it is a nature-induced force, and not sure about, but whatever guideline is given by the code, so following this code, following this guideline, one can estimate the seismic forces, and accordingly some of the features that needs to be provided while designing the bridges. Wave pressure, grade effect, all the different types of the forces are there. We were discussing about the live load. Majority of the country has made some sort of a standardization and defined certain class of the load that needs to be considered in the design to ascertain the live load which are to be there. So depends on the category of the bridge, category of the road, which category of the road is there, whether it is a village road or whether it is a SHRB state highway road or major district roads or national highway or express highway. Right? or of a specific importance. So depends on this importance of the load. Certain guidelines are given to consider what kind of load needs to be considered in the design. So code has prescribed the class AA track vehicle, wheel vehicle, class A wheel vehicle somewhat about 55 ton, class A that is a 70, class AA that is a 70 ton load. This is class B discuss what is the carriage, what carriageway width is there, how many lanes are traffic lanes needs to be considered, and in these traffic lanes what kind of loads are required to be considered. All these different things are there. Different loads combination needs to be carried out. In a buildings we have a very few loads that needs to be considered, but here the live load itself you will find out a lot many different combination of the loads needs to be tested, needs to be studied to ascertain the maximum loads, maximum bending moment, maximum shear force, maximum deflections. So to ascertain the maximum condition which we need to carry out a different load combinations. Forces that acting on the bridges that to be considered. First thing is the vertical reaction from the superstructures. So vertical reaction because this is, let us say, the intermediate pier is there. So on one side there is a superstructure, other side, so vertical reaction that is from span 1, vertical reaction that is from span to span 1, that is if we consider on left hand side, span 2 will be on the right hand side. So these are the vertical reaction. Longitudinal moment due to net vertical reaction of the superstructures or from the live load. Many times there may be a different type of the superstructure. It's not necessary. On one side there is a larger span, on other side there is a lesser span. On one side, because if the span difference will be there, there may be a different type of the superstructures. So there may be a different weight of the superstructure on one side, other side the thing is there. So that is why this differential reaction would also involve a longitudinal moment. So this longitudinal moment that is given here, that is because of the differential superstructures that is to be provided on left and right side of the thing is there. In addition to that, the live load, as we know that the live load is a moving load, so we need to consider a different condition. Let us say that one span is loaded, other span is empty, or maybe both the spans are loaded. So all these different possibilities needs to be considered as per the code prescribed or code suggestions. So because of that also there is a moment, and that is called a longitudinal moment. Horizontal force due to braking or there may be a braking conditions. So braking condition would also induce a longitudinal moments, and seismic condition, low braking condition in the longitudinal directions. So that will induce the longitudinal moment. Same time, transverse direction. This is the longitudinal direction. This is the transverse direction. So in the transverse direction, transverse moment due to the eccentricity of the load. If there are a multi-lane loads, multi-lanes are there, it's not necessary that every time all the loads are to be equally flooded. So because of the eccentricity of the vehicles, there is a transverse moment. So transverse moment due to the eccentricity of sometimes the superstructures. There may be, let us say here, the footpath is there on one side and it is not to be there on other side. So this is called the eccentricity of superstructure, eccentricity due to the superstructures or due to the live load. The transverse moment will be there, and horizontal force due to the wind or seismic in the transverse direction also the horizontal force would act, and that is why the transverse moment will be there. So this all these are the forces. Conceptually, I have tried to explain that what force needs to be considered in the design, and accordingly, this is one of the RCCT girder bridges. Let us say it is a somewhat of about 7.85 meter span, and two spans are there, so 16.32 meters. So the thing for this, I'll just giving you some of the figures of this RCC girder bridge. So for RCC girder bridge here, see, let us say 8.4 meter, 7.5 meter is a clear width. So So 7.5 meter clear width is there. 8.5 meter is the overall width, right? So it is a gradient of 2% slope is given, and span is somewhat about 7.85 meters. So that is why the depth of the girder is kept a 1 meter. The depth of the girder will be dependent on what is your span. Normally, for RCC girder, span to depth ratio of L by D ratio of 12 to 15 can be provided. 15 can be provided for a pre-stress kind of a range. 12 can be provided for a RCC bridge. So span to depth ratio of 10 to 15 can be provided for the girder kind of a bridges. More will be provided for the box type of a bridges. So based on span to depth ratio, one can decide, one can estimate the dimension, and accordingly, all this this is see here, the spacing between longitudinal girder is kept at 2.7 meter. So all these criteria are decided based on either some expert experience or by thumb rule, or having some experience will be able to get such kind of some initial dimension. See, in any design, initial dimension needs to be assumed, and then after we can do a detailed design and prove that whatever dimension we have kept is to be appropriate or not. If it is not, then we have to redesign the things. So even in the building design also, we are doing the same thing. Initially, we can assume the dimension, and accordingly, we can check later on that everything is found to be proper or not. So this is the things. See here that particularly near the span, we can go for a higher. See the things is there. So let us have that RCC girder. See here, some portion the enlarged section is provided, whereas it is the things. So this is the transition portion. Here the same cross section is there. Here the width will be reduced. This is the cross sectional or the diaphragm, intermediate diaphragm or cross girders, and this is the end diaphragm which is provided. So just to have, it is a half bottom plan, half top plan, and at the end of the bridges we need to provide a abutment. So here abutment is provided at the end of the bridges. Here this abutment may be either a cantilever. Here the counterpart type of abutment is provided. So some counterparts are provided at regular interval because it all depends on what is the height of the abutment. If the height of the abutment is more, we need to provide a counterpart. So counterpart type of abutment is provided here just to take care. This is the cross section which is provided 1 meter depth, and you can see here that larger width is provided at the support and lesser width is provided in the mid span. At the same time, haunches also needs to be provided just to take care of the stress concentration. So this is all the initial cross-sectional dimensions to be provided the things. Main design steps involved a data load calculation, analysis of superstructures, summary of from design and detailing. Right? I will just go ahead. I will let us confirm with the organizer how much time I can go ahead.
Sir, we have 5 to 10 minutes left, sir.
I take 10 minutes more.
Okay, sir.
10 minutes. Can I go to 10 because we have started a little late.
Yes, sir. What doesn't matter.
Let's take all the participants. Please please bear because we have started a little late. So you will see, you will get a beautiful videos of the construction. I will not discuss construction much detail, but I will show you the video so that will give you more clarity that what are the advanced things which are going on, advancements which are going on as far as the construction is concerned, right? So I'll try to just compile everything in a very short time of 10 to 15 minutes. So these are some of the data which is required in the design: center to center bearing of the span, carriageway configuration, a number of main girders, cross-sectional properties of the main girders, dimension of the deck slab, SIDL, grade of the material, everything which we need to decide before we start the design. In the load calculation, dead load, that is due to the deck, longitudinal girder, diaphragm. These are the dead loads. Superimposed dead load, that is due to the crash barrier, curb, footpath, wearing coat, railing, whatever the things are there, that will part of the superimposed dead load. Live load depends on the class of the vehicle. Whatever vehicles needs to be considered. For that, we need to follow the code guideline. IRC guideline has already given for different class of the vehicle that needs to be considered. At the same time, number of lanes. So at a time, there is no need to how many numbers of lanes are there, and what is our load combinations and everything that is prescribed in the code. So which needs to be followed as far as the live load is concerned. Analysis, it involves two kinds of analysis, approximate and final computer analysis. Nowadays, I think computers are easily available, computer softwares are also available, so people are not going for approximate analysis, but grillage analysis is widely used. So one can easily make the grillage of the longitudinal girders and the cross girders, and whatever loads are to be there, that we can put it. Everything, I think computers and softwares are very easily available to us nowadays, and that is why this grillage analysis is widely used in all the design offices. Used just to check the results whatever comparison. It is assumed that entire this deck and everything is to be rigid, and that is to be on the girder. And if any eccentric loads are there, what is the contributions of all these eccentric loads on these girders? If it is a concentric loads, it is assumed that all the girders are to be equally distributed. But if it is an eccentric load, how the load will be distributed on the different girders? So accordingly, the reaction factor of each girders will be decided, and accordingly, considering the total load, how much reaction factor would be there. So by assuming that the entire thing will be behave in a rigid manner, but as we know that many times the behavior is not. Of course, it is a RCC girder, is a rigid girder, but still, if it is a long span bridges are there, then these theories are not found to be appropriate. So that is why these Kerbin's methods are being not much suitable, particularly for the flexible structures. If it is a rigid structures, it is okay, but flexible long span structures, this method is not suitable. Grillage method is widely used for any kind of whether it is a flexible or a rigid, it can be there. And as you can see that the grillage is to be made here. So these are the supports. So support to support, there is a longitudinal girders. So you can give the girders support longitudinal girder. Here by having a already all the facilities are given in majority of the computer software. So you can give the property of the longitudinal girder, you can give the property of the cross girders. You can here see the different types of the loads, either class A load, class AA load, whatever loads are that is to be prescribed, so that you can give here. And whether it is a static load, whether it is a moving load, everything will be very nicely, efficiently taken care by computer software. And with the help of the grillage analysis, I think not many combination you will find, because every load position is a one combination of a load. Remember, so that here you can consider different load positions are there. So you will find out a lot many load combination. Maybe sometimes to analyze all these 1,000 load combinations and to find out the worst effect, right? So nowadays the software, computer and software is essential, without which the bridge design cannot be carried out, remember, right? So with this thing, these are some of the features, how to go for ideal these are some of the recommendations as far as the analysis is concerned. Girder, exterior girder, head support, at mid span, everything we can get it, and then after we can go for we can make such kind of a table to find out the maximum moment due to the dead load, live load, SIDL, and one can find out the maximum moment, maximum shear, and in the outer girder, inner girder, everything, all these things can be carried out, and then after we can perform the design, whether it is RCC design or whether it is a pre-stressed concrete design of girder that is known to many of you, so that you can I will not go into the detail, but the design can be carried out either it is a RCC or pre-stress. As the time is short, I am not going to show the drawings of the design in detailing, but I will move on the construction aspect and showing you some of the construction issues. So this design and detailing, the drawings are available, but right now because of the time constraints, I am not going to show you. Right, construction methodology, where RCC bridge, pre-stress bridge, precast, cast in situ, steel. I will be more discussing about the precast concrete bridges, and particularly segmental and full span. There are various mechanization is available nowadays, and with the help of these mechanizations, one can easily carried out. Right, so deck slab may be cast in situ, or either it is RCC or PSC. Most of the time, it may be a RCC or precast. Precast segmental technique, it complete a deck cast, entire deck cast, deliver and erected in the unique cells. Segments are pre-stressed together using the external tendon or internal tendon. Joints can be a dry or wet, it can be decided, and whole typically span by span or balance cantilever method is used. Its advantage is structurally efficient and aesthetic, and basically complete with the deck when it is erected. So it is a rapid construction, can be fast. And main important thing is that we can start the superstructure and substructures. Overlapping activity can be carried out together. So as the substructure will be going on, parallelly the casting of the superstructures are going on at the casting yard. And casting yard and logistic that needs to be set up. So this is only the disadvantage, but otherwise the method is a fast. So precast segmental erection can be carried out in different way. Erection on false work by gantry, span by span or balance cantilever, by crane, by lifting frame, by erection technique, full span erection techniques. These are some of the pictures will giving you the idea. The false work, we need to create a false work, and over the false work we can go for the construction. This is just by with the help of a gantry, this can be put it on the false work. So false work needs to be created here, but sometimes there is a difficulty, as we know that the viaduct portion is there where it is difficult to create the false work, because vehicles are continuously traveling in the viaduct portions. So at that time, we need to go for a different options like erection by gantry. So such kind of a gantry can be created, or we can even go for a crane. Such kind of a cranes can be established, and the gantry can be established over that. One can go for span by span construction. I will show you the video that will giving you a more clarity. These are some of the pictures. This entire methodology of construction, erection and construction needs to be given in the drawing. How one by one span is going to be created with the help of this gantry, that needs to be given in the drawing. So construction sequence is playing a very, very important role, and slowly and gradually with the help of a crane and gantry, the construction will progress. Right? So this is the things. With the help of such kind of a launching girder can be also established. So before that, already the substructure is casted over which the launching girder is going to place, and now whatever units these are casted in the nearby casting yard, that can be shifted to a side, and then after it can be put it like this. So all these segments can be put first of all together, and then after we can go for the pre-stress. So this kind of a launching girders. This kind of a girders can be also used for the balance cantilever. So as the construction progress, one by one element is to be put on the left side as well as the right hand side. Right, one element put on the left side, one element to be put on the right hand side. Such kind of launching girders needs to be established at the support, and with the help of a balanced cantilever techniques, one can the progress will be going on. Right, so these are some of the photographs of the launching girders that is provided. Launching girder as well as cranes. We can also go for a cranes if the launching girder is not provided. The cranes can be also set up so that the balance cantilever can be carried out. And this is by the lifting frame. So these kind of lifting frames to be installed, and it will be progress slowly and gradually as the construction will be progressed. Right, so lifting crane can be done, and this is another full precast span erection segments. Right, this is again a full precast span erection segments. I actually would like to show 2-3 videos, but as the time shortage, I will just avoid the 2 videos. I'll show you only one videos. This is a videos of the span by span construction. I think majority of you might have seen for the metro construction, so I will just avoid it. This is also construction of a steel arch bridge. Of course, it's a very nice thing, but I will again just leave this video because of the time constraints. And construction of the bogie bill. I think this is a this is remarkable structures which is made by the Hindustan Construction Company. Bogie bill, many of you might have seen the bogie bill, and I would also like to show you the video of how the construction of this bogie bill is going on. Right. So I'll just show you only one video because of these time constraints, and let us have this video of a bogie bill, and Professor Kaushal,
Yes, sir.
just the last video, and we'll finish this talk.
Okay, sir.
Will take not more than 5 minutes.
Okay, sir. Doesn't matter.
Please let me know whether video is the screen of video is visible.
Yeah, it's on screen.
Yeah. Voice is audible.
Might be window might get freezed, sir. That's why voice is not there.
ચાલુ છું. જોડ થઈ જશે So I think see how the construction is going on. Mechanization is nowadays available in the field of bridge engineering, so that will make this construction exciting. So with this thing, I'm going to end my talk here. Time is 2 hours. Time may not be enough to discuss the everything, but I try to cover some of the design aspect as well as the latest construction techniques which are going on. Hope you enjoyed things. Thank you.
Thank you so much, sir, for sharing your knowledge with us. It's a pleasure to be able to listen your valuable words and gain knowledge from you. Thank you again, sir, for giving your precious time. I'll request all the participants to feel free to ask any questions or query if they have any related to this session in the chat box, or you can directly contact the faculties through WhatsApp.
Hello, good afternoon, sir.
Yeah, good afternoon.
On the behalf of the participants, on the behalf of GEC Dahod, I'm thankful to you, sir, to spare your time, valuable time, and give in detail depth knowledge related to this topic, sir. Now, sir, there are certain questions which will be arised by the participants. So, sir, can we start, sir?
Yeah.
Please, sir, provide the name of software for analysis of bridge.
Pardon?
Provide the name of software for analysis of bridge.
Software, yeah, exactly. See, there are specialized softwares available for the bridge design, but in the absence of some specialized software, you may also use a traditional software like a STAD or SAP or that thing. That also you can use it. Otherwise, MIDAs are also available for the bridge design. LUSAS is also available. So MIDAS, LUSAS, these are some of the softwares which are available particularly for the bridge designing. But if such softwares are not available, you can even use a STAD, you can use a SAP. The thing is that analysis part is the important thing. Later part, in the design part, you can use Excel and you can customize the Excel spreadsheet in such a way that the result of the software can be imported to a Excel spreadsheet, and you can make your design spreadsheet so that the design can be made. Majority of the design offices are doing the design in this way, right? Some specialized bridges are there, like suspension bridges or cable stay bridges, and this construction sequence analysis needs to be carried out. Rail structure interaction needs to be carried out. So whenever some specialized task is required to be carried out, at that time we need to have softwares like MIDAS or LUSAS or this kind of a softwares are there which can tackle such kind of a specialized task. Otherwise, this kind of a task you may even take with the help of a STAD or other software, but for that you need to have some sound engineering of using the software, and that you will be able to do it, right? I hope you may get the answer.
Thank you very much, sir. Actually, sir, there are so many appreciations which has been written by our participants, sir. Sir, really thankful to you to share your views. And sir, now I can say that why I am calling you, sir. Why I am calling
actually,
you, sir?
the thing is that I am really very sorry for that. Initially, there are some difficulties for starting the session.
Sir, it is to be understood, sir, because this is technology, sir. Technology, sir. It is to be understood, sir. But sir, now I will tell you once again, sir, why I am calling you, sir. So frequently, sir, whenever I will arrange such a kind of FDP, I will be there for you, sir. You have to arrange. You have to spare some time for us, sir.
It's my pleasure, and it's the love and affections of you towards me, right? I'm always ready, and I'll always give my level best whenever you will call me.
Thank you, sir. Now, sir, there is no further questions from the participant. But sir, I kindly request you that just like previous time you send the
Sure.
PPT,
I will send my presentation and
yes. Okay.
Sure.
Sir, the thing is that I have sent you certain WhatsApp. Just check it out, sir. WhatsApp, sir. Just check it out the WhatsApp. It's not an issue, sir. It's not an emergency. Just check the WhatsApp at your convenience and reply, sir. Now, participants are kindly requested that there is a break for at least half an hour. We will start our second session at 1 o'clock sharp. Thank you very much.
Okay, thank you. Thank you all participants, and thank you organizers, especially Professor Kaushal. Thank you.